Today we're doing limits, and first of all, you need to have your equation, right? Then you need to find your horizontal asymptote and your vertical asymptote. Horizontal asymptote, there's no x right here, it's non-existent. So the horizontal asymptote, because the x is less on the top than on the bottom, would be 0. Then vertical asymptote, you set this to 0. And solve it. So the vertical asymptote would be positive 4. So go ahead and mark that on your graph. And now that you have that, you want to test the limits. So basically, because your vertical asymptote is 4, you want to find one number less than 4 and one number greater than 4. So you basically plug these two numbers into your x. So let's start off with 3. Plug in 3 for your x. So it'd be 3 minus 4 be 6, or negative 1 should equal negative 6, which is less than 4. So we know we're going down from here. And then we plug in 5. So it'd be 6 over 5 minus 4 would be 6 over 1, which would be positive 6. So that lets you know above the horizontal asymptote. So then once you do that, you look at your limits, and it's going from x to 4 from the left side. So because it's on the left side, you know that it'll be negative infinity, because as you're approaching 4, it goes down all the way to infinity. So this would be this would be negative infinity. Then as you do it from the right side, you know as you approach 4, your y value goes all the way up to positive infinity. So then your limit would be positive infinity. And then for your overall limit, because neither of the lines actually will ever hit positive 4, your overall limit would be undefined.
Part to infinite limits, which you need to find c to figure out what the two limits are. So first we must pull the denominator from x minus 6 to flip the number to find our c. So you would do plus 6, which would equal the c, which is 6. And then after that, when you come down to the limits, when you look at x to c plus, it means plus means you look to the right of your c, which you would have to make an equation. And I would do a number that makes it a whole number, not a... Okay, after you find c, you look at the limit and you go from x to c plus, which makes it where you have to find a number bigger and greater than your actual number c, which you could pick 7, 8, 9, but I prefer to pick a number that does not have a decimal in it, so I would pick 9. So I would put f to the 9, and then I would put 3 over 9 minus 6, which would equal 1. And if you get a positive number, the number would become infinity. If you get a negative number, it becomes negative infinity. So on this one we got positive, so it would be infinity. And then for x to the c of negative, you have to try to find a number lower than c, which I picked 3 just for the heck of it. Okay, now for testing our second limit, we would look at x to the c negative, which means the number would have to be smaller than 6, because it has to be to the left of 6. So I would pick a number like 3, so it wouldn't be negative, so it would be f to the third equals 3 minus 3 to the minus 6, which would equal 3 over negative 3, which would equal negative 1, which would make the number become negative infinity because the number is not positive. So I would get negative infinity.
So for our first example, we're trying to find the limit of x going to positive 2 from the right side. And our equation is 2 over x minus 3 squared. So first of all, we have to find the vertical asymptote. And to do that, all you need is the x minus 3. Set it to 0. Solve for x. So your vertical asymptote would be x equals positive 3. So our next step is, because you're coming from the right, you need to pick a number that is greater than 3. So we're just going to choose 4. So it would be 2 over 4 minus 3 squared. So it'd be 4 minus 3, which is 1, and 1 squared is obviously 1. So it'd be 2 over 1, which would equal 2. So because it is a positive number, the limit going to 2 from the right side would be infinity. And that's it.